Okay, I'm recording a new video for Unit 5. We're getting into newer material in this course that has been updated in recent years. And I've done a fair amount of updates to this in the last 2 years, including this year. I apologize if some of you may have looked ahead at this. There were some old links and stuff, and this material is just getting out of date. So I really wanted to get it updated somewhat. So, um, format is basically the same. We have the Unit 5 plan here. We're going to be talking about a number of chapters. We're kind of going to skim over 3 chapters again here. The idea is that a lot of this stuff has been replaced by newer models. And so we want to kind of cover it quickly, but we do want to cover it because it's the foundation of a lot of the stuff that's going on now. In particular, we're going to look at recurrent networks here. And natural language processing. And this will lead us into large language models and stuff like that. A good kind of view of this is this sort of structure here. This comes from a video that Chris McCormick recorded at some point and shows these recurrent models, recurrent neural networks, long short-term memory networks that we'll kind of look at this week here, and how they kind of are a builder for encoder-decoder networks. And that led to this whole idea of attention. And once we had attention, that led to transformers. And that led to, this was when BERT was the best model out there, but that basically led to GPT and all the large language models. So you can just put any LLM up here for that. And so again, we're going to be covering this sort of stuff here. So the chapters are chapter 15 on processing sequences using, again, recurrent neural networks here, and also language processing. Now, the next whole course in this CIS 6117 is all on language processing. So we will also be skipping over some of this because you'll be covering it in that here. And so we're also pulling in more, again, in the chapter 17 is on representation learning, and particularly generative learning with autoencoders and GANs. Again, GANs have largely been replaced with newer image generation techniques, particularly diffusion models. And so we won't be doing too much on this, basically replacing it with some information on image generation. And we'll talk a little bit more about attention in prep for next week. Again, we're kind of moving beyond some of the stuff and talking about transformers here, which is the architecture that's predominant in machine learning today. So we do have 2 notebooks here that'll introduce these 15 and 16. I've had to do updates to these. But again, this walks you through some recurrent neural networks, how to process, how we kind of send sequences of data into our things and work with what we call time series. Again, sections of data that are sequential there. So again, this might be measurements that from a sensor that's measured repeatedly. It could be things like language where we have each letter in a sequence. Any data that has a natural sequence to it is generally what we call a time series, and we put it in here. Again, we won't do too much time. Again, there's whole areas of this because the stock market is certainly, and stock prices and commodity prices are all time series, and so there's a lot of experts working on this and trying to predict this. We'll cover it relatively briefly here. So this will walk you through, and we'll do some forecasting. We won't be forecasting Bitcoin prices. We'll be looking at forecasting sunspot data and stuff like that here. And then we'll get into language processing again with RNNs, and we'll start talking about attention here. This was where attention was first kind of developed and created. So we'll talk about using this, and again, using these recurrent neural networks to process data. Now, what turned out to be is that recurrent neural networks turned out to be very slow and hard to train, but they developed attention. And once we got attention, that led us to getting rid of the recurrent part and just sticking with the retention here. So So those are the two notebooks we'll be covering today. I've deleted another notebook because it was kind of tied to this chapter 17 stuff and some of the 16 stuff on language translation because it was just too out of date here. And I replaced it with some image generation stuff. So along with that, we have some learning resources here. Again, we're kind of getting away from some stuff that's in the book. That's a little, book is a little outdated here. So we have this learning resource for image generation talking here. So let's go over this. So here we're talking about encoder decoder models. And again, this is covered somewhat in your book. The idea here is that we're feeding a sequence in and we're encoding it into some internal representational space, some maybe state space or some internal, sometimes called a latent space here. So we encode like words into these numeric vectors, sometimes all tokens or something like that. Then again, you'll do more with words and stuff like this in the next course if you take that. And then that is fed to a decoder, which takes those words and tries to predict like the next word for this sequence or the next sunspot amount or the next stock price. We encode, get our internal represent, and decode things. We can also do multiple, we can encode to some, again, meaning space or latent space here, and we can have multiple decoders that generate text and different things. So this is often how language translation might work. We'll start an encode into some latent or meaning space here, and then we could, this might be English here, and then this might be decoding into Spanish, or this might be decoding into, French or some other language here. So that's our general model. Now, this is with language. We also see something similar for images here, where we encode, we send an image in, and we generate an image out for this. And the model that we often talk about here is called UNet for this. We'll put in an image, and we'll generate a new image, often a mapping of that here. So we see this a lot in medical images, where like we'll put in an image of a CAT scan or an X-ray and try to be maybe detecting cancer or some sort of particular cells or whatever. And then this one will generate that image, will have highlighted or circled or marked what the cancer cells or something like that. We also see this in like smart cars, where we'll send in an image of the driveway or the road ahead, and then we'll partition that image and we'll identify, oh, this is a bike ahead, this is the roadway ahead, these are trees, this is a car approaching, and we'll encode that in the output in different ways. And a UUNet is a convolutional neural network, which we looked at last time, where we have these convolutional layers, we have a max pooling layers, convolutional layers, we get down to some flat layers here. But then rather than just predicting something, we will regenerate these convolutional layers and build up the image until we get an image generally the same size as the input image. We also have these. So this layer will look at the feature map from the previous layer, but also look at the image that was originally put in here and generate that. And these are very good at generating images based on other images, but they have to be based on an original image often and do something with that. A lot of what we think of image generation now will use a different model for this. So, and again, here we have what are called the encoder or decoder. We talk about this being the encoder. We get into some latent space or meaning space here, and this is the decoder for that sort of idea. So the book is going to talk about image generation with generative adversary networks, where we have this really cool idea. We send in random noise. We have a generator generates a fake image. We have another network that looks at real images and fake images and tries to predict which one is real and fake. And then these two networks compete. This keeps trying to generate better and better fake images, and this keeps learning to discriminate, tries to learn better to discriminate between these, and we train these two models in together to generate image. This turned out to be a challenging training process, and so today we generally don't use these GANs, these generative adversary networks here too much. And again, we want to talk about them because they're useful and have some history. But again, we're largely using what are called diffusion models today to generate noise or images. So I'm going to show you that sort of stuff. Um, I really like this introduction to just the video. I think you may have to log in. Let me just show you this with your CSS ID or some sort of Google ID here. It is just part of the Google Hub training area for this stuff. And it walks you through these GANs. I want to jump to a certain later on in this video here, where again they're talking about these diffusion models and stuff, and particularly they go, yeah, they talk about this process of taking a model. Oops, go back just yeah. This side. Let's go back just as talking about learning how to um, have a noisy version of image and generate a clearer version of it, and training a model to remove basically noise from an image and clear it up, enhance sort of idea for it to clear it up. And we can, or, we could take a image and make it noisy, but generally we're doing this way. Now, once we do this in one step, where we just may have a little bit of noise on it, and then we're clearing up that noise, we'll move into this sort of process where we'll take really noisy image and slowly make it reduce more and more noise, make it a less fuzzy, and we train our models on, oh, here's a semi-noisy model. Can you remove just some of the noise from it to get to the next model? And we can easily generate these images. We can take a noisy image and add more noise in it and train a model to take that more noisy image and generate a less noise. I'm not just describing this well. You should watch this video if you can and work through this stuff. So this is, I think, a good video that walks through at least the section that I highlight here. Minutes 1:15 to 5, basically, I think are very useful here. Google also talks about their particular image generation technique, and if you want, you can read more about it here. Hugging Face is I don't know if we've talked about Hugging Face, but we're getting the modern AI sort of stuff. Hugging Face becomes more and more important. They have a lot of models, large models that we can access and stuff, and they have a lot of guides and information there. And a lot of this is public domain. So they have a nice introduction to stable diffusion if you're interested in that. And that is one of the main things that does this sort of generation, this diffusion guide. So we'll be trying out a bunch of image generators. So here's some you can try out. I'll post this list again in our assignments. You'll see this. Now, image generation has a bunch of legal and ethical issues, so we're going to talk about those. In fact, there's a bunch of issues here, which you're going to either talk about in the discussion post or in the write-up here. So let's jump into the write-up. Some of this write-up, again, relates to the first 2 notebooks that you'll be doing there. And then we get into encoder, decoder models. And again, some of this is covered somewhat in our textbook. If you can't find a good source for this in the readings, feel free to search and use Google or some other thing to track down an answer to this stuff. I used to have a notebook that did some of this stuff here, and we've since removed it. Now this write-up 7, all this is tied to this learning resource on image recognition and these questions that are come up there. Each one of those, so write-up 7.3 ties right up to this 7.3, where you get to answer this question for that. Okay, so that's the write-up in the learning resource. Now, we do have 2 other learning resources. One is on tokenization. I think that's really cool, but tell you the truth, you'll be covering tokenization a lot in your next course. So in my undergrad course, we cover it here and do it here, and you're free to look through this there, but you'll be covering this in your next course if you take that stuff. So like I say here, it's very optional, and I'm just leaving it here because in my undergrad version of this course, we cover it at this point. And again, we'll be talking about tokenization when we get into transformers. So if nothing else, just read enough of it to know that words are converted to tokens, and tokens are vectors or lists of numbers that represent words here. Let's do this quick review leading into transformers. So with transformers, we'll be getting into something, this attention mechanism, and I just want you to read up a little bit about attention here. So IBM has a good article on attention and what it is for this and why it's important for this. I think this is a good thing to read through. It's more up to date than some of the stuff in your textbook here. And like I say, preview will be next unit. We'll be covering the seminal article, probably in all machine learning for the last 10 years, is attention is all you need. And basically that shows that you can get rid of recurrent connections and just use attention for this. So here, let me just show you. This is a presentation I do to review machine learning in our course. So again, we cover some of the traditional machine learning techniques here, but for this course, I want to, and again, we cover deep learning, get into convolutional neural networks and how they're set up. We talk about recurrent neural networks. That's what we're kind of doing now, these types, and convolutional neural networks here. And we build, we built more complicated convolutional neural networks and stuff like that. And then we get into the sequence-to-sequence networks or encoder-decoder networks, kind of the same idea where we're encoding a set of words and we're decoding a set of requests. So like here, this is the incoming email, and this is an output email. This might be a sentence in Spanish, and this might be a sentence in English here. And we have some here they call it a thought vector or a latent meaning space or some sort of internal representation of this model for this. So I'm going to, again, I'm going to skip over some of the stuff on learning for now and just focus on, and again, part of this that we're going to need is tokenization, what tokenization is here, and what attention is here. So again, we'll be encoding. This latent space is going to be kind of replaced by this attention mechanism, and then we'll be generating the output here. So again, we're feeding in input. This looks like input in German, and we're feeding it through an attention mechanism here, and then the output here is being translated into English. Or maybe this looks like French for that. So, and that's going to lead to us to what we're going to see next week is this transformer model where we'll have what these attention blocks within this. So again, we're just kind of showing you the buildup of what led to transformers. A lot of these models weren't created from scratch. They were built on previous models, which are evolved from previous models and evolved from previous models. So this is just to kind of show you some of that evolution, in particular the attention, which I don't think the textbook covered as well as I would have liked. Okay. So that's the learning resources. So what do we have to actually do this week? So again, we mentioned the write-up. The project this week is a little different because I want to give you a little more time to start looking at the final project here. So what you'll be doing is generating some or working on image generation things. So you'll have a set of tasks for image generation here. So one thing is just see how accurate test out image accuracy. You'll try to generate the image here. I have a standard prompt I like to use, and that is college students ice fishing in Minnesota. I like to see what they generate there because I know it's a kind of challenging prompt, amazingly, for some of these models to do and look for things here. So your idea is you're going to use, there's a whole list of image generation techniques here. You're going to pick one of these here that you want to try. And hopefully some of these will let you create images. And again, you have to check, and it's constantly changing which ones. But again, I'm just going to try this one so you will want to try your own prompt here, but we'll do that. And again, pick one of these image generation methods and generate some images for this. Now, it's really fun to see what other students, what other ones are. So what I'm going to do is break you into teams. And I do this much more in my undergrad teams. We work in teams regularly. And so you as a grad student may not be used to this. So here's how we're going to do this. And don't be worried. It's going to be fine here. I've done this lots of times. So you're like, here's team 3 here. So this is team 3. Whoever starts first on this will take this write-up, we'll make a copy of it, and we'll share it with the other team members. So if you don't see your team members, and then I would just email them that. And then again, you'll go up here and you'll share it with those team members with their email addresses there. So let's say Karen decides to start this early and starts working on this early in the week. She would make a copy of this and share it. Now she's student 2. She just has to do the blue part. So like this one is student 1. She'll skip over that. She'll do student 2's stuff and paste her images here, her prompt. Her images will be placed in again. So here we did a thing. We'll grab that image. We'll paste it in here. And stuff, and it will analyze the image. How was this image? How particularly look at things like the hands, the face. I like to look at the reels, and are these ice fishing reels or whatever you want. And then delete that because I don't want it actually in there on yours. There's some paste your images, and then later on, there will be 3 of you will be doing this, and you can see each other's analysis as you go. So the first one is just accuracy of images. The next one you want to try is privacy and misinformation here. So you should try to generate an image of a famous or semi-famous person or character doing some activity here and see what you can do. And again, if you are the student 2, you only have to do this one. And again, I will only grade 1. So if you do this, you're student 2 and your other 2 teammates never do anything, that's fine. You'll get full points. As long as you do all the student 2 stuff, if you're student 2, you'll be good. So that's why, and it's kind of color coded here. So again, if you are student 1 here, you have to do all the green parts. Student 2 has to do all the blue parts, and student 3 have to do all the orange parts here. So you'll do that and you'll share it. And it's kind of fun then to see what your fellow students create. It's kind of like a mini discussion area with just the 3 of you there. Okay, so that's our project. It's a kind of special project. I don't think it'll take as long, hopefully for you, and it'll be kind of fun here. And the idea is that we're at the point where you should start looking and thinking about the final project. And so you're not going to be running any code, so you can start, hopefully have some time to think about this final project. The last thing is the discussion post. And again, the discussion post is talking about legal or ethical issues in image generation and finding articles about it. All right, that's the assignment this week. Let me know if you have any questions. Thanks.